In this video we will learn how does a thermal power plant work, how does it convert energy from fuel into electricity. Well, thermal power plants use water as its working fluid, and here we will understand working of a thermal power plant in a logical step-by-step manner. So the basic question, how electricity is produced? And here is the answer, using a generator. And if we can rotate shaft of the generator, we can produce electricity over here. In thermal power plants, we will rotate this shaft with the help of a steam turbine, like this. You can connect a steam turbine to the generator shaft. And if you can rotate blades of this turbine, you will get electricity over here. The next question, how to rotate blades of this turbine? Answer for that is this. Supply a high pressure, high temperature steam at the inlet of the steam turbine. Thanks to high pressure and high temperature of the steam, it can rotate blades of this turbine. So you can generate electricity over here. So you can consider steam turbine as heart of the power plant, which eventually absorbs energy from the fluid. So we have achieved our objective, we have produced electricity. But the main challenge here is how to produce this electricity continuously. Means, when this high pressure, high temperature steam passes through this turbine, the blades will rotate, so the blades will absorb some energy from the steam. So steam will obviously lose some energy. So at the outlet of the steam turbine, you can see the fluid is having low pressure and low temperature. So if somehow you can bring this fluid back to this original state, to high pressure, high temperature, then you can have a continuous process over here. So we'll get continuous electricity from generator side. So that exactly is our challenge in a steam power plant. How to convert this low pressure, low temperature steam back to its original state. Means to a high pressure, high temperature steam. Before finding how to do this, we will analyze this process more thermodynamically. I have drawn two graphs here. One is pressure volume graph, next is temperature entropy graph. So these are vapor domes of steam. Means inside of this dome is mixture of liquid and vapor, and right side will be completely vapor and left side will be completely liquid. And this is our starting point, a high pressure, high temperature steam. And during this process, we know pressure decreases. So in a pressure volume graph, the pressure will come down. Since this is in a gaseous state, obviously the volume will increase with decrease of pressure. So this will be the curve. It's an adiabatic process. And in temperature entropy graph, you know temperature is coming down during this process. And there is no heat addition or heat absorption to the fluid. So this is a constant entropy process. So you can draw it like this. Temperature is coming down and entropy is constant. Now back to the basic question, how to increase pressure and temperature to the higher level. So you have two objectives, first increase pressure, next increase temperature. If you want to increase pressure of this fluid, obviously there will be an answer in your mind. Just put a compressor after this, right? Your answer is right, but the problem is, if you want to compress a fluid which is in gaseous state, you will require a lot of energy. Means such a power plant will have a very low efficiency. Instead, if you can convert this fluid into liquid state, then the compression will require very less energy, or it's more easy to compress. So before increasing the pressure, we'll convert this steam into liquid state. For that, what you have to do, you have to reject some heat to the surroundings. Like this. You put a condenser over here that can reject heat to the surrounding. So vapor will get transferred into liquid state. Now this process can be drawn in PV and TS diagram like this. And during heat rejection there is no pressure change because fluid is free to expand. And obviously this is phase change, so temperature cannot change. So this is in TS diagram. Now the fluid is in liquid state. Now you can put a compressor and you can raise the pressure. Here it is. A compressor is connected right after the condenser. So you can see pressure rise in PV and TS diagram like this. Pressure has increased to the original state. And you can see volume of the fluid doesn't change over here. This is because we are compressing a liquid. When you compress a liquid, there won't be much change to the volume. The change of volume will be minute. And you can see the same process in TS diagram like this. There will be a slight increase in temperature. It's almost negligible anyway. First objective is over. We have increased the pressure now. Now we can concentrate on how to increase temperature back to its original state. Answer is simple. Just add some heat to the exit of compressor. So it will be like this. We will use a heat exchanger called boiler, and we can add heat from outside to the fluid. So obviously temperature of the fluid will increase back to its original state, and you can see it over here. Temperature rises from here to its original state. And during this process, pressure remains same because fluid is free to expand. Now the cycle is complete, and this cycle is known as Rankine cycle. And this is a basic Rankine cycle. In order to execute this Rankine cycle in a power plant, you will need some other accessories, especially for heat removal and heat addition. We will see that. So forget about thermodynamic cycles now. First, for heat rejection, if you want to remove heat from this fluid, you have to supply a colder liquid through this heat exchanger. And for that purpose, we are using something called cooling tower. A cooling tower always will have a cold water inside that, and you can pump it over the condenser and it will absorb some heat. Finally, it can be cooled back to this original state using natural conversion phenomenon. Now next, how to do this heat addition practically. For that, you will use something called a boiler furnace. In a boiler furnace, heat is supplied continuously to the water inside the heat exchanger, and this heat can be produced with combustion of coal or with help of nuclear energy. Assume your fuel is coal, then you have to powder the coal first, and this pulverized coal can be supplied to the boiler furnace. Here it will get mixed with air and it will produce tremendous amount of heat. But during this combustion process, since the fuel supplied is coal, it will produce lot of pollutants. There will be lot of ash, suspended particle, sulfur. So you have to handle this exhaust very carefully. And handling of this exhaust gas will form a huge portion of power plant in fact. It will be done like this. First you will take the exhaust out, and it will pass through an equipment called electrostatic precipitator. Here most of the suspended particles are removed. Now the exhaust gas is much cleaner. That can be jetted to the atmosphere with the help of stack. Before winding up the lecture, we will have a look at current world power production scenario. You can see coal and nuclear combinedly produce almost half of world's power, and both comes under thermal power plant because working fluid of both are steam. Hope you got a logical introduction to working of thermal power plants. Thank you for watching the video. Have a nice day.